Hello, everyone, and welcome to this latest webinar from IHS Markit titled, Can Low Power Wide Area IoT Networks Capitalize on 5G Confusion? LPWA technologies for IoT applications have become a leading concern in the telecom industry for several reasons. So today our panel will provide clarity on the evolving LPWA landscape through industry research and real-world development experience. Our webinar is co-presented by IHS Markit and our partner Telit. My name is Alan Tatara, Senior Event Manager for the IHS Markit Technology Group webinar team, and I want to thank everyone for joining us. So before we get started, I want to highlight some features that are available for you on our webinar on how you can make the most of your experience with us today. So the console that you're looking at is completely customizable, so you can open, close, move, or resize any of the windows that you have open on your screen and arrange the console to suit your preference. Now, at the bottom of your console are a number of application widgets which contain additional features available for you. I do want to mention the resource list widget, and this is where you're going to find additional material about today's topic, including the downloadable slide deck from today's session, as well as other valuable resources, including a special report authored by our own analyst, Sam Lucero. And all these materials can be accessed and downloaded right from your console. And we did include a Twitter widget. You'll see that at the bottom of your screen, and this means you'll be able to tweet directly from the console. And today we are using the hashtag LPWA. We will also have a live Q&A session directly after the presentation, so please submit your questions or comments at any time by using that Q&A box that's on the left side of your screen. And if you encounter any technical issues during the webinar, just click on that question mark widget, and you will get the answers that you need. So now let me introduce our panel. First leading our discussion is Sam Lucero. Sam is Senior Principal Analyst of the M2M and IoT segment at IHS Markit. And along with Sam, we are joined by Marco Argenton. Marco is Product Marketing Manager of Cellular IoT Solutions at Telit. So welcome to both Sam and Marco. It's great to have you with us. So let's get started with our presentation. So Sam, I will turn it over to you.
Great. Thank you, Alan, and welcome, everyone. We certainly appreciate everyone taking time out of your busy schedules to be with us here today. I'm just going to spend a bit of time providing an overview of the LPWA market for context before handing over to Marco Argenton from Telit. So the Internet of Things is having a transformative effect on numerous markets and technologies. Specific to wireless connectivity technologies, the desire to address IoT use cases is blurring the lines between different categories of wireless standards. For example, some low-power wireless technologies like Bluetooth are effectively increasing their range through mesh networking technologies. Some short-range wireless technologies like Wi-Fi are increasing supported battery life through low-power operation. For cellular technology, a key effort is underway to address typical IoT use cases. This effort is typically referred to as low-power wide area, or LPWA. And it involves optimizing cellular technology for use cases and applications that need very long battery life, require low-cost components and connectivity services, are expected to be deployed in massive volumes, and only need to transmit relatively low amounts of data. This optimization effort for cellular technology has resulted in two primary standards, eMTC and NB-IoT. eMTC is also referred to as LTE-M. Additionally, when we speak about the application of these standards to remote equipment, the term LTE Cat M1 is used for eMTC, and LTE Cat NB1 is used for NB-IoT. There's actually also a third standard called ECGSM, which has been developed, but it so far hasn't gained much traction, and so we won't spend time discussing it today. In addition to these two cellular LPWA technologies, which operate in operator-owned licensed radio frequency spectrum, there are also several non-cellular LPWA technologies that are designed for IoT use. I'll focus on comparing Cat M1 and Cat NB1 to the two unlicensed LPWA technologies that currently have the largest mind share, namely LoRa and Sigfox. In addition to the licensed spectrum, unlicensed spectrum difference, there's also an important mobility difference. Cat M1 remains closest to its LTE roots and provides a somewhat traditional cellular mobile experience in terms of handing an ongoing connection from base station to base station as needed. This could be important for IoT applications needing to maintain a voice connection, such as, for example, an emergency wearable device. The other three LPWA technologies shown here have a much more limited set of mobility capabilities, and while they could be appropriate for intermittent tracking, would not enable the same maintenance of an ongoing voice connection, for instance. Module cost is another important factor to consider. Both Cat M1 and Cat NB1 feature costs that are currently much more in line with 2G module costs than broadband LTE module costs. And Cat M1 and Cat NB1 costs should decrease even further in the coming years as chipsets are optimized and volumes increase. Even so, LoRa and Sigfox feature even lower module costs, with Sigfox publicly announcing a $2 price point, although it's not completely clear at what volumes this price point applies. Finally, I'll just note that there is an important difference in the relative ecosystems supporting these technologies. Both Cat M1 and Cat NB1 are 3GPP standard technologies with the support of the global ecosystem of cellular chipset providers, module vendors, equipment makers, operators, and so forth. LoRa has collected a broad ecosystem of supporters, but faces somewhat of a bottleneck at the chipset supply level of the value chain. Chipmaker Semtech owns the IPR to LoRa, and while the company has licensed IP rights to STMicro and Microchip, this is not currently as robust as the cellular ecosystem features in terms of chipset supply. Sigfox does not have the same bottleneck at the chipset supply level because it simply uses standard sub-gigahertz RF chipsets, which are available for many suppliers. Sigfox's bottleneck comes at the service level of the value chain. So Sigfox owns and operates, for example, the sole source public networks Sigfox public networks available in France and the US. In other countries, Sigfox partners with one local entity per country to deploy services. The partner, called a Sigfox network operator, has exclusive rights to deploy the network in its respective country. Typically, these partners are alternative connectivity service providers, such as Arqiva in the UK. Just to put a finer point on it, LPWA technologies are meant to support large numbers of low data rate, infrequently transmitting devices. LPWA technologies are distinctly not optimized for high-speed communications or for low latency use cases. For high-speed or low latency devices, traditional broadband LTE or Wi-Fi and eventually 5G technologies will be more appropriate. Now, the LPWA market over the past several years has gained tremendous prominence, especially as mobile operators become increasingly focused on supporting IoT applications. But LPWA as a concept is actually not very new at all. Proprietary technologies for private LPWA deployments have been available since the early 2000s. These include, for example, meter maker Elster's Waveness smart metering communication technology. Until 2015, however, LPWA technology was a niche, almost afterthought aspect in the overall wireless connectivity market, with small shipment volumes and even smaller industry mindshare. The first LPWA market inflection point came in early 2015. Sigfox raised a massive $115 million third funding round and followed this in 2016 with a $160 million funding round, making it, incidentally, the best funded venture-backed company in French history. The 2015 funding round especially was a significant wake-up call to the traditional cellular industry, which increased its own efforts to develop 3GPP-based LPWA standards. Likewise, the LoRa Alliance, which is an industry organization, gained significant traction in 2015 and now totals over 500 member companies. Apart from any market visibility or ecosystem traction, a key development with Sigfox and LoRa has been the support for public network services over unlicensed wireless spectrum. This has enabled alternative service providers such as cable operator Comcast in the U.S. with its new LoRa-based so-called machine queue offering to compete directly with mobile operators in providing wireless wide area IoT connectivity services. In June 2016, the 3GPP finally standardized Cat-M1 and Cat-NB1 as part of its LTE Release 13. Trials commenced in late 2016, and commercial services are now available in a number of countries, if on a limited basis, with the global network footprint growing rapidly. Crucially, Cat-M1 only requires a software upgrade to the base station. Cat-NB1 may require older base stations to be replaced, but many newer base stations can also be software upgradable. This enables MNOs to largely reuse their existing network infrastructure, which has been amortized, obviously, globally across billions of phone subscribers. Eventually, as we'll cover in more detail later in this webinar, the upcoming 5G new radio or NR standard will incorporate LPWA characteristics and functionality. But IHS doesn't anticipate this happening until well into the next decade, as the industry first focuses on increasing broadband speeds and supporting ultra-low latency use cases. Even after a 5G NR LPWA technology is developed, we anticipate that LTE-based LPWA technologies will coexist to the end of the 2020s and into the 2030s. So, quantifying LPWA market growth by module annual shipment volume, and I mean here total shipments on a global basis of both licensed and unlicensed LPWA technologies, IHS forecasts that the market will grow from 28.3 million modules shipped in 2016 to over 382.9 million modules shipped in 2021. Both Sigfox and LoRa clearly had a head start over Cat-M1 and Cat-NB1. However, the traditional cellular ecosystem is moving quickly to get licensed LPWA services deployed. And toward the end of the forecast period, we believe a steadily increasing share of module shipments will be represented by Cat M1 and especially Cat NB1 modules. I should also add that as a reflection of how quickly this market is evolving, IHS is now in the process of researching and preparing an update to this forecast. And it's likely that this forecast will be substantially increased in the final years based in large part on the tremendous growth occurring and anticipated in the China market, especially. The Chinese central government, for example, is very actively involved in promoting the adoption of Cat NB1 in the country and issued statements in June of this year stressing the support and the need for the 3 Chinese operators to increase even further their focus on rapidly deploying Cat NB1 services. Okay, I just want to shift gears a bit and focus more squarely on cellular IoT and the implications of 5G on the market. As I've touched on previously, the development of licensed LPWA and 5G is occurring in the context of optimizing for IoT, optimizing networks that were originally developed for voice and broadband data access. So key objectives for LPWA use cases include dramatically lowering power consumption to enable devices to function on battery power for up to 10 years, reducing component and service costs to below that currently available for 2G technology, dramatically scaling up the number of devices that can be supported by a single base station up to around 100,000, and improving the robustness of the connection to increase both the range and the ability for signals to penetrate into basements or a few feet underground, for instance. "5G adds an important new element to that ability of the cellular industry to address IoT use case needs. I've focused until now on the needs of LPWA use cases. 5G adds significant or will add significant support for mission-critical IoT use cases. This support mainly revolves around sub-1 millisecond latency, as well as extremely high reliability and availability. Essentially, the goal is to expand the addressable IoT market in an entirely new direction and support applications such as autonomous vehicles, closed-loop industrial automation, and remote surgery. Finally, and very quickly before handing over to Marco, I just want to reiterate that Cat M1 and Cat NB1 have long lives ahead of them. They will continue to be developed and deployed as the 5G standard develops and after 5G deployments begin in earnest after 2020. For example, an interesting new avenue for 3GPP technologies is in unlicensed spectrum, both in public but also private network deployments. This could dramatically expand the addressable market for 3GPP LPWA in and of itself. So let me, at this point, pause and turn it over to my colleague, Marco Argenton from Telit.
Thank you, Sam. Hello, everyone. Thanks again for joining us in this webinar. I'm going to tell you something about the problems and the challenges that we are facing with the upcoming technologies. But before entering into a couple of technical aspects, let me tell you something about market trends. And I want to spend a few words, for example, on the security segment, so that we can touch a real scenario where we have experienced the migration of the technology that our customers are forced in a way to implement in their products. And this is true also for other segments, of course. But in particular, I'm thinking to the US market, where the 2G shutdown, for example, is already in place, or in other countries where the roadmap of the major mobile network operators is already in execution for the phase out of 2G first and 3G after. So the security segment is moving away from 2G, and also in Europe, the region from where I'm talking to you is also relevant for this discussion, because even if we don't have a problem of phase out of 2G in the short term, because it still represents a large volume of connection for the next years to come, for all those applications that are requiring a longer lifespan, and we are talking about 10 plus years in the field, the customers are forced to think to the new technology. And in general, if we look at the building and security segment, we have also to realize how this is the one with the highest forecasted growth as a result of this 2G sunset at global level. And of course, this growth is leveraging the upcoming new radio access technologies. Just as a background information, the first, let's say, mandatory move away from 2G and 3G in some markets has been to focus on LTE category 1, because it was the first possibility to adopt a lower cost technology compared to LTE category 3 or category 4, and still offering voice over LTE, offering enough throughput to transfer images or videos. So this was the first, let's say, migration when the operators announced their plans for the phase out of the technologies. But now we are in front of the LPWA adoption. And if we look at LTM and narrowband IoT, these are technologies with the highest CAGR in the next 5 years. In particular, if we talk about LTM, we have a percentage of 51.3%. Narrowband IoT is even higher with 107. So these are technologies that are representing another game changer, because they are offering a lower cost, maybe lower throughput, okay, but for a lot of IoT applications, this is still good to support several use cases, including the voice capabilities that, as you can understand, is relevant for the alarm panels, for example. So this segment is, in my opinion, a good example to show how the different technologies in the recent past and in the next future are changing. A good example to show also how Telit can be helping and supporting the customers in this migration. And the next question would be, okay, but what's next with 5G? And this is the reason for which we are here to discuss this topic. Well, the message that I would like to transfer to you is that LPWA is now, and it must be considered without hesitation, because for sure it opens new opportunities and also new revenue generators for the end users. 5G is for sure coming, as presented by Sam in the chart a few slides ago. It is coming in 2020, but in 2020 is more a matter of fixed broadband applications and high throughput applications. And for IoT is more a, let's say, 2025 story. So there is no problem of compatibility issues. To address these use cases for low power, extended coverage, etc., LPWA is a technology that can be used now if there is the need to move, of course. And we will see in the next slide how this technology will enter into 5G, but without any problem, as I said, of compatibility. 5G will be, I like to use this example, a big umbrella embracing several aspects. So,
Great.
Sam, if you want.
Okay. Sorry, Marco. Yes, let's pause for just a second here and actually get some audience feedback now on your own interest in and potential use of various LPWA technologies. So as you see on the screen, we're asking you a very brief poll question. Is your organization considering the deployment of an IoT application using LPWA technology? Please take a minute and provide a response. That could be yes, most likely using LTE Cat M1, yes, most likely using NB-IoT, yes, most likely using an unlicensed LPWA technology, Sigfox or LoRa, yes, not sure which LPWA technology to use, yes, but we'll use multiple LPWA technologies in the solution, or no. So just take a quick second and we'll pause, and then okay, I see answers still filtering in. I'll pause for a few minutes, for a few seconds more. Allow anyone who is still making up their minds about their response. Okay, at this point, I think the rate of responses have slowed down. So let me switch to the poll results and let's see what we have. So, okay, so the responses are interesting. In terms of having a firm idea of the technology they're going to use, it seems fairly evenly split, either using M1, using NB1, or using an unlicensed technology, with more of the respondents indicating they're not sure. And very interestingly, the plurality of respondents actually saying they will use multiple LPWA technologies. Marco, what's your reaction to this? How does this conform with experiences you've seen, for example, working with your customers, or any other thoughts or observations you have on the results we've received here?
Well, I can tell you that I'm not surprised at all by these results, because this is the perfect confirmation of the statement that we often say, that there is no one technology that fits all the use cases. And this is also the reason for which Telit is investing a lot of resources in developing a broad portfolio of products and solutions that are covering all these LPWA standards, and also covering the different regions, because I'm sure that in the audience there are customers with different use cases, different requirements. Some of them probably is expecting to have mobility and voice. Some other could be stationary and using data only. Some other could be willing to deploy a private network. So this is why we see this fragmentation in the market. And so I can definitely confirm that this is not surprising, but we are here exactly for this reason, and willing to help everybody that needs the support to go to market with this technology.
Great. Okay. I just want to remind the audience as well, please keep submitting questions for the Q&A section at the end. And with that, let me turn it back over to Marco for his portion of the presentation.
Yes, sure. The title of this session was Problems and Challenges. So let's see what we're talking about. I decided to call this slide multiple standards to serve multiple needs. And this is also in line with what we just said to comment the results of the poll question. And in particular, when talking about 5G, most of the people are thinking that 5G is related to high throughput. Typically, everything that is above gigabit per second is considered 5G, even if it is not formally correct. And the other buzzword is low latency or mission-critical applications. But telling the truth, yes, these are the game-changing aspects of the 5G radio interface, but this is not everything that 5G will address. And we would make a big mistake if we consider 5G only addressing these two aspects, because it would mean that we are not giving a future to all the devices that are relying today or in the next future on the LPWA technology. In reality, there is no confusion, because LPWA is paving the path to 5G. So summarizing the three major aspects and scenarios of 5G. On one side, we have the massive content, so what someone is calling extreme mobile broadband. And here the use case is definitely the speed, the throughput. On the other side, we have the massive sensing. So this is exactly the area where LPWA devices will fit into the 5G evolution. So simple devices with very limited throughput and with the requirements of low power consumption. So massive machine type communication that will enable the growth in volumes of the ecosystem. And last but not least, the massive control, what is called the ultra reliable communication or the mission critical applications. So here the use case is the one that I mentioned before, the low latency. Everything that is related to response time, for example, of 1 millisecond. And since I was mentioning the security segment before, let's try to see how this will evolve. And in my analysis, I will say that there are specific requirements and needs in this segment that could be split into two major areas. One is the areas of the mission-critical applications, so emergency and real-time notifications, and on the other side, the massive low-end IoT, so everything that is related to the data collection and reporting, a lot of sensors that, for example, today are not even connected to the cellular network. Maybe they are just connected into a local network with some proprietary technology, but not yet on the cellular network. So these are the two major areas. There is the third one as well, because when we think about security, for example, a typical scenario is the video surveillance applications. And in this case, we are talking about throughput to transfer high quality video, and so this is the area of the extreme mobile broadband that could play a major role in 5G as well. So today there is not a technology that is tailored for each of these sub-segments. We can use LTE category 4 or even higher for extreme high throughput. We can use low power wide area for the data collection and all the sensors, but in the future, the cellular communication will be able to support all these use cases within the 5G network architecture and infrastructure. And we will see in a second how.
Great. Marco, just before we move on, can you give some other additional real examples of ultra-low latency machine-type communication applications?
Yes, of course. Let's say that, first of all, when we think about mission critical, typically the first buzzword is related to low latency, okay? But this is something that could be relevant for verticals or applications such as drones, such as autonomous driving, everything that is requiring real-time feedback. But when we talk about mission-critical applications, it's also a matter of highly reliable transmission. This is why I put this scenario in the security segment as well. Because there are situations, if you think, for example, about real security issues or remote monitoring of the health of the people that are living in the house. We're talking about scenarios where we cannot accept any loss of communication. So this is, for me, a mission critical. This is something that, for me, will find new implementations and new products in the future when the technology will bring us to the 5G ecosystem.
Great. Thank you, Marco.
So, okay. So let me go to the next slide where I try to give you an explanation of how all the different use cases will be able to coexist. The solution to this problem that we have, or to this challenge that we have just analyzed, is the so-called network slicing. And many technologists explain 5G metaphorically like a big pizza cut into multiple slices, each with its own combination of toppings that appeal to different people. So in this analogy, 5G has also multiple slices designed to accommodate different applications. So as the name implies, network slicing is a process by which wireless carriers can slice up a single physical 5G network into multiple virtual end-to-end networks that are individually optimized to service the requirements of various connected IoT devices. So this is really a key capability because it enables the flexibility and it allows multiple logical networks to be created on top of a common physical infrastructure. So as you can see in the diagram, we could have the different scenarios and the different use cases, each of them with the peculiar aspects. For example, self-driving cars or drones that I mentioned before for the low latency applications that are requiring also high bandwidth. They are in the massive content, for example. We could have virtual reality streaming smartphones requiring medium latency and high bandwidth that are in the other section, and IoT and M2M sensors that are requiring lower bandwidth and medium latency that are in the third part of the pizza, let's say. But of course, this is not a matter of slicing into three parts that are the three major sub-segments that I explained before. There could be multiple slices, multiple virtual networks coexisting in order to serve the different requirements and use cases that the IoT ecosystem in 2025, for example, will present and that we will have to support with our products and with our solutions. To finish this part, let me give you a deployment application example. Again, to remain consistent with the discussion that we had so far, if we go back to the scenario of a smart home, and in particular related to security applications, we see how there could be different connected products into our intelligent house of the future. Some of them could requiring massive content, because, as we said, video surveillance is one of them. Some of them could require mission-critical resources, and I'm talking about emergency calls or anything that is related to e-health, etc. And then we have all the sensors that could be deployed into the house for fire monitoring or flood detection, whatever you want. Everything will coexist, as we have just seen. And on top of that, all these technologies will be able to transfer simultaneously their data to the 5G network, and on top of that, we could have services to manage the data that are coming from these devices. And this is where Telit can also play a major role, because we can not only enable the connectivity for all the scenarios that you can imagine on the left-hand side of the slide, but also help the integrators with our connectivity offering and with the services on top of it that will enable the users to control, for example, remotely their devices. Okay, so let me hand over to Sam again for the conclusions.
Thanks. Yes, great. Thank you, Marco. So we are coming towards the end of the webinar, and I would just like to spend a quick minute recapping some of the key points. LPWA technology will enable a migration path for 2G and 3G based IoT deployments. So for all of those current use cases that are already out in the field, LPWA provides a runway past the anticipated sunsets and spectrum refarming that is going to happen globally over the next decade, really. Second, LPWA expands the overall addressable IoT market for cellular IoT. So this isn't just about an upgrade path. It's also about enabling devices that couldn't have been previously addressed with wide area wireless connectivity to be addressed, be supported. Third, current LPWA technologies will be supported to the end of the next decade or even beyond. So we think that there's going to be a long runway for development. Fourth, 5G will eventually incorporate LPWA attributes, although we again are suggesting that the focus initially will be on increasing broadband speeds to multi-gigabit and to reducing latency down to 1 millisecond. So the focus is not for 5G NR on developing replacements for LPWA features and functionality. 5G will expand the addressable IoT market to mission-critical use cases. So Marco went into quite a bit of depth around this. And then 5G also entails enhancements to the core network that will benefit IoT applications. And likewise, Marco went into a lot of detail there as well. So let me hand over to my colleague, Alan, and look forward to continuing with Q&A. Alan.
Thank you, Sam. And now is the opportunity for you to submit your questions and comments. I know many of you have already, but keep those questions coming, and our panel will be addressing those momentarily. Also, just a reminder to make sure that you check out our resource list widget down at the bottom of your screen to download not only the slides, but a special report from Sam and some other valuable information as well. So with that, Sam, I will turn it back to you so we can get on with our Q&A.
Great. Thank you, Alan. Okay, so the first question is, do you think today's proprietary systems will eventually be killed by cellular standards? And related question, is multi-fire an important part of this to offer unlicensed as well as licensed cellular-based LPWA? Let me actually quickly address the second piece first, and then we can go from there. I definitely think that the work that is underway now to move LTE into unlicensed spectrum, and this is happening initially with traditional broadband LTE, but is expected to be this effort is expected to be ported over to LPWA as well, I think is a very key development. And I think I alluded to it in the presentation, in the webinar itself. So being able to deploy over unlicensed really expands the opportunity, both from an economic standpoint for certain types of operators and even alternative service providers, but also really expanding the addressable market into the private network domain. And that has really been that private LPWA network domain. So if you think campus-wide networks or connectivity for a large building even, or a large agricultural facility or a large industrial facility for that matter, where there may not be public network infrastructure, base station infrastructure that can readily address and service that location. Or there may be some business-related reason for wanting to manage a private network in regards to the deployment. Unlicensed spectrum is a key enabling capability or key enabling media for being able to have that kind of deployment. And so LoRa certainly has gained a lot of traction through that facility for not just being a public LPWA technology, but also facilitating those private networks. And so to the extent that the 3GPP ecosystem is also successful in exploiting unlicensed spectrum, I think it's only going to be positive for NB1 and M1 and their derivatives. Marco, did you want to also add in here?
Just a comment on the question, specific question on multifier. We didn't put the name of this protocol in the chart that you presented, but it was clear the reference when we were talking about the unlicensed working group that within 3GPP is actively working on the evolution of the and integration of unlicensed technology within 3GPP. And I definitely agree and think that this is important. The unlicensed technologies like LoRa and Sigfox have today definitely an advantage of being the early mover in this IoT ecosystem for LPWA, but the evolution of the standard, of course, we don't have the crystal ball, but definitely could help the growing of additional applications and users in the license spectrum as well. So the question is important, and I'm not saying that it will kill the unlicensed, but definitely it will contribute to the evolution of the possible use cases in the future.
Great. Okay. So another question is, will LPWA emerge completely within completely separated market segments for ultra low power communication applications with very low data rates, no video, no voice, just sensor data, etc. The requirements are completely contradictory to high-speed 5G. So my impression of that is yes. I mean, we see now that environmental sensing, tracking low-value assets are areas where having LPWA is enabling applications that really would not be enabled or get off the ground or be justify a positive business case were it not for some of the specific features, functionality, characteristics of LPWA. So environmental sensing is, for example, probably not going to really ever be enabled through 4G. You know, possibly, you know, some applications, environmental sensing applications were enabled by 2G, but those will obviously be going away over time. So that is my perspective. Marco, did you have a perspective you wanted to share here as well?
With regards to this question, I just want to say that I'm glad to see this question, because it is related to what we try to explain today. So yes, the requirement, as it is written in the question, are completely contradictory to the high-speed 5G, etc. But in particular, as we try to explain in the second part of the webinar, 5G is not only about high speed or low latency. So there will be a coexistence of low data rates, no voice, no data, no video, no voice, just sensors, and high-speed applications in the future network that 5G will represent. So no contradiction and coexistence. This is my message here.
Okay, great. What is LPWA's plan to working with the 5G standard, or any collaboration between LPWA and 5G? Well, as I tried to allude to during the webinar, we think that the focus of 5G technical development in the near term, that is, you know, through the middle of next decade, is really around increasing the speed to multi-gigabit, and to increasing the or reducing latency down to about 1 millisecond or less. So our research suggests that most industry participants don't view LPWA as a critical development need for 5G NR because, well, simply there are options available today. So with NB1, with M1, with LoRa, with Sigfox, in the market today, spending development cycles on 5G and our LPWA is just not seen as the most critical priority at this time. We do think that eventually work on 5G and our LPWA technology will commence, and it will be part of a 5G NR radio. And at that point, we'll probably enable even longer battery life or more efficient operation or better capabilities around location-based services or direct point-to-point direct links and mesh networking as opposed to everything being in the cellular base station model. But that's not LPWA is simply not where 5G, the organizations and the companies working on 5G, where they are spending the bulk of their time today. Marco, I don't know if you wanted to add to that.
No, I don't have anything to add. I'm okay with your answer. And maybe if we have one more minute, I could take the opportunity to answer another interesting question that I see that came that is related to the LPWA deployments. If we believe that they are likely to be mostly single mode or dual mode. For example, utilizing multiple LPWA connectivity technologies. I think that this is a good question, in particular in this transition period where the market is still fragmented. We see a big traction of Cat M1 in US, while maybe Europe could give the feeling that narrowband IoT is more popular. There are for sure solutions that we also have under development that are combining different technologies. For example, Cat M1 or narrowband IoT. I would say that it is not to serve the use case of the product itself, but maybe to make sure that there is the connectivity wherever the device is going to be. There are other scenarios in which a licensed plus a non-licensed technology in the same device could be instead be considered as a backup solution. For example, failure of the main network and using the second one as a channel to communicate, hey, there is a failure. So yes, there are situations in which we could see dual mode and instead use cases where, for example, if you are in US, you are going to deploy with AT&T only, and you are sure that you have Cat M1 coverage, there is no need to add additional cost to the product for having alternative solutions. But when it's a matter of having products that are requiring mobility around the globe, this could be something to consider.
Great. Okay. I think we're coming to the top of the hour, so let me just pass over to my colleague, Alan. And Alan, please take it away.
Thank you, Sam. I want to thank everyone for participating on our webinar today and also for submitting your questions and comments. Sam, special thank you to you for leading our discussion, as well as Marco. We appreciate you sharing your experience with us today. So an archived version of this webinar will be available shortly, so feel free to come back again to view this session or even share it with your colleagues. And you will see a short survey pop up at the conclusion of this webinar. We'd love to get your feedback, so please take a few moments to fill that out. And lastly, make sure you follow us on Twitter for information on future IHS Markit Technology Group webinars. So again, thank you for joining us, and have a great rest of your day.